Hello, dear students. Uh, Today, let us start fourth part of our motion in straight line. Okay. Uh, to understand these things better, what average velocity and average speed, let us solve some of the problems. Only some problems, so as to understand. Yes, sir. So as to understand your average speed and average velocity. Okay. Okay. Brother, okay. Here is a problem given. Calculate the average velocity and average speed in the following graph. Okay. Let me draw this graph now. This is a graph. Okay. This is origin O. Let us give for plus 40, 80, 120, 160, 200, 240, 280, 320, and 360. Let this be equals to x, say, in meters. What you have to calculate? You have to calculate average speed and average velocity. Where from O, say, first point is P, second point is Q. Okay. Calculate the average velocity and average speed in the following graph. Calculate the average velocity and average speed in the following graph. Case 1. When a body, say a car, when a car travels from O to P, first condition. Second, it will somewhere here. Okay. From O to P and then P to Q. O to P and then P to Q. Okay. And third, from O to B and then back to P to O. What we have to do? We have to calculate what average speed and average velocity. This problem is given in textbook. Okay. Maybe in some other form. I use the same scale as given in textbook. Okay. But what we have to do? We have to just calculate its average velocity and average speed. Okay. See the problem neatly. I have only limited area of board. So I am supposed to what? I am supposed to rub the problem. Okay. This is just to make you understand what is the exact difference between your average velocity and average speed. Okay. This is okay. See. Average speed is equal to total path length divided by total time taken. Total path length divided by total time taken. Correct? We are discussing about speed. So, total path length is, in first case, see here, you are traveling, a car travels from O to P. In first case, if we are traveling from O to P. So plus 360. Okay. Let me mention time here. From O to P, time is equal to 18.0 seconds. Time taken by the particle car to move from O to P is equal to 18 seconds. It is important. Time is important parameter. Correct. Okay. From see from P to Q. P to Q, say 6.0 seconds. Let me repeat. Time taken by this car to travel from O to P will be equal to 18 seconds. Exactly given in your textbook. 18 seconds. O in the P ಹೋದಕ್ಕೆ ಆ ಕಾರಿಗೆ 18 ಸೆಕೆಂಡ್ ಬೇಕು. From P to Q. From P to Q, time required is 6 seconds. 6.0 seconds means 6 seconds. Okay. So in first case, what we are calculating? We are calculating average speed. So for total path length is 360, actual path covered divided by total time taken is as given in problem. This is meter 18 seconds. Okay, we just cancel it. 18 for once 18 to the 36. It will be equal to 20 meter per second. Here your average speed is 20 meter per second from A to B. Sorry, O to P. Now, this is Q as usual. This is P. Here, in first case, let us calculate average velocity. Average velocity. Average velocity is equal to what? Displacement. Displacement divided by time interval. What is displacement? This is initial point. This is final point. Say somewhere here. This is x2. Final point is x2. This initial point is x1. So displacement is x2 minus x1. x2 minus x1 divided by t2 minus t1. t1 stands for time when object was at x2. t1 time when object was at x1. First initial position. Okay. So what I have to write here? I have to write here plus 360 divided by t2 is 18 seconds as given in the problem. 18 seconds. Okay. What about T1? T1 is 0. When the object was at O, when object was at O, its initial time was 0. Okay. Next. So once again, what we get? We get same answer, 20 meter per second, but I have to mention direction along OP. Along OP. OP ಯ ದಿಕ್ಕಿನಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. OP ಯ ದಿಕ್ಕಿನಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. Here we observe one thing. What? The motion being in straight line, one dimension, your average speed is equal to magnitude of average velocity. Your average speed is equal to magnitude of average velocity. Let me repeat. As object is moving in straight line in one direction, we observe that your average speed is equal to magnitude of average velocity. See, these two answers are equal. This is 20 meter per second. This is 20 meter per second. Why? Because both are moving in same direction. Here displacement is equal to path length or magnitude of displacement. Correct word is magnitude of displacement is equal to path length. Hence we get this answer. Okay, case 1 is over. Case 2. In case 2, this is case 1 anyway. In case 2, your object has to move from O to P initially, then P to Q. What I am telling? Your object must travel from O to P in first instant of time, then P to Q. So, what about average speed? Average speed, as you actually know, this is total path length divided by time taken. So, total path will be OP plus PQ divided by total time T1 plus T2, where T1 stands for first interval, time for first interval from O to P is T1, P to Q is T2. So OP plus PQ is equal to T2 plus T2. Okay, visible I think. Okay, I can write here also. So OP is as usual, it is 360 plus what is called PQ. See here, this is PQ. Somewhere here, PQ. Difference is 40 meter. 40, 40, 40. It is 120 divided by time is 18 seconds plus 6 seconds. This is meter. Okay. And then more other, I will write here 360 plus 120, 0 plus 0, 0, visible, visible, 0 plus 0 is 0, 2 plus 6, 8, 1 plus 3, 4, 480 divided by 18 plus 6, 18 plus 6 will be 24 seconds, 180 meter divided by 24 seconds. Okay, you can do it yourself also, no doubt in that. So what we get here, I will write average speed is equal to, average speed is equal to 24 one time 48, 24 two times is 40, 24 ones are 24, twos are 240. So once again we get what, 20 meter per second. See here, 24 1, 24 twos are 48, 20 meter per second. In this case, your average speed is 20 meter per second, where when your body travels from O to P, then P to Q. Correct? Okay. Average velocity is what? Displacement divided by time interval. What is displacement? Now this is initial point O and this is final point. Anyway, we have started from O, reached P and then back to Q according to your problem, according to this graph. But according to definition of displacement, it only depends on initial point and final point. It's independent of path followed. Here, path followed by you is never important. ಇಲ್ಲಿ ನೀವು ಯಾವ ಪಾತ್ ಅನ್ನು ಫಾಲೋ ಮಾಡಿದಿರಿ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗೋದಿಲ್ಲ. ಏನು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗ್ತದೆ? ಅದು ಓ ಇಂದ ಶುರು ಮಾಡಿದೆ, ಅದು ಆರಂಭಿಕ ಸ್ಥಾನ ಆಗಿತ್ತು, ಕ್ಯೂಬ್ ನಿಂತ್ಕೊಂಡಿದೆ, ಅದು ಅಂತಿಮ ಸ್ಥಾನ. ಸೊ ಹಿಯರ್ x2 will be 240. x2 ಎಷ್ಟು ಇಲ್ಲಿ 240. x1 0 as usual. x1 ಏನಾಗಿದೆ 0 ಆಗಿದೆ. So displacement ನಾನು ಬರೀತೀನಿ ಪ್ಲಸ್ 240 ಅಂತ ಬರೀತೀನಿ. x2 minus x1 ಬರೋಕೆ ಹೋಗೋದಿಲ್ಲ. x2 240, x1 0. What about time minus t0? Okay. t2 means time when object was at its final position. ಇದು ಫೈನಲ್ ಪೊಸಿಷನ್. ಇಲ್ಲಿಗೆ ಬಂದಾಗ ಎಷ್ಟು ಟೈಮ್ ತಗೊಂಡಿದೆ ಅದು ನೋಡಿ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗೋದಕ್ಕೆ 18 ಸೆಕೆಂಡ್ ಮತ್ತು ಪುನಃ ಇಲ್ಲಿಗೆ ಬರೋದಕ್ಕೆ 6 ಸೆಕೆಂಡ್, ಒಟ್ಟು 24 ಸೆಕೆಂಡ್ ಬೇಕಾಗಿದೆ. ಟೈಮ್ ಯಾವಾಗಲೂ ಎಡಿಷನ್ ಆಗುತ್ತೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಇನಿಷಿಯಲ್ ಟೈಮ್ ಏನು? ಇನಿಷಿಯಲ್ ಟೈಮ್ 0. ಇಲ್ಲಿ ಏನು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬಾರ್ದು, 18 ಮೈನಸ್ 6 ಮಾಡಬಾರ್ದು. ಟೈಮ್ ಹಾಗೆ ಸಬ್ಟ್ರಾಕ್ಟ್ ಆಗಲ್ಲ. ಟೈಮ್ ಏನಾಗುತ್ತೆ, ಯಾವಾಗಲೂ ಎಡಿಷನ್ ಆಗುತ್ತೆ. ಒಂದ್ಸಲ ಟೈಮ್ ಹೋಗಿ ಮುಗಿದು ಹೋಯ್ತು ಅಷ್ಟೇ ಅಲ್ವಾ? ನೀವು ಓದಿಂದ ಪೀಗ್ ಹೋಗೋದಕ್ಕೆ 18 ಸೆಕೆಂಡ್ ಬೇಕು, ಫೈನ್. ಪಿದಿಂದ ಮತ್ತೆ ಕ್ಯೂ ಬರೋದಕ್ಕೆ ನಿಮ್ಗೆ 6 ಸೆಕೆಂಡ್ ಬೇಕು. ಒಟ್ಟಾರೆ ನಿಮ್ಮ ಟೈಮ್ 24 ಸೆಕೆಂಡೇನೆ. ಆದರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾತ್ರ ಏನಾಗ್ತದೆ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾತ್ರ ನಿಯರೆಸ್ಟ್ ಪಾಯಿಂಟ್ ಆಗ್ತದೆ, ಶಾರ್ಟೆಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಗ್ತದೆ ಅಲ್ವಾ? ಸೊ ನಮ್ಗೆ ಏನ್ ಸಿಗ್ತದೆ ಈಗ? ವಾಟ್ ವಿ ಗೆಟ್ 10 meter per second we get. Here is the difference. In second case, magnitude of, I can write along OQ also, along OQ. In this case, see, some Swati Vinayak Bhatt, she has written an exact answer. I am saying that. Okay, good Swati, keep it up. You did right. Okay, see here, 10 meter per second. 10 meter per second. Here, magnitude of velocity is not equal to average speed. Magnitude of average velocity is not equal to magnitude of average speed. Difference is there. Okay. Hope you understood what is the exact difference between your average velocity and average speed. Now, in third part, in case 3, what you have to calculate? You have to calculate object from O to P, which takes 18 seconds, and then P to O. Once again, let us consider 18 seconds. Time remains constant there. Okay, what you have to calculate? You have to calculate total average velocity as well as average speed. Okay, do it in your home. It is homework. Part 3 is homework. Our case 3 is homework for you. Okay, nice. Let me take one more example, some standard example. Remember this formula, whatever it may be, speed or velocity. It is a formula connecting 3 factors. One is velocity or speed. Velocity means with the direction, speed means without direction. In that sense, I am telling velocity or speed, say v, distance traveled or path length, say x, divided by time. What we have to do? Here we have 3 things to be connected. 3 things connected. V is equal to x by t, where v is your velocity, x is displacement divided by time. This is a basic formula. In most of the competitive exams, like FDC, SDC, KPSC exams, CET, or any general PDO, sub-inspector, police, in such exams, there is a general paper. In that general paper, they used to ask such questions. What relation between velocity, displacement, and time? Okay, let us consider one very interesting problem. Okay, I will write like this. Problem number 2. A body, a car better, a car is moving from A to B, A to B with a speed of 40 meter per second. A car is moving from A to B with a speed of 40 meter per second and returns from B to A by increasing its speed by 50%. 50% of initial 50% of initial speed. What do we mean by 50% of initial speed? Initial speed was 40 meter per second while going in one direction. Okay. While coming back, okay, 50% speed increased. Okay. 50% of initial speed. Calculate average speed and average velocity. Nothing is given. Only speed is given. As I told, speed is given by speed is equal to distance divided by time. Distance divided by time. Okay. Solution, let me write. Let me draw this in terms of picture. Let's understand. This is point A, this is point B, this is point A, and this is point B. And a car is going in this direction, 40 meter per second. Here, from B to A, 50% of 40 meter per second. 50% of 40 meter per second. Not actually increased. The speed is increased by 50% of, like right, increased at 50% of 40 meter per second. What is distance between two positions A and B? Not given. The distance between A and B is not given. Let us assume the displacement or distance. Anyway, it is motion in straight line. Let x be the distance between two positions. Okay? While going from A to B, body will cover x distance. From B to A, once again x. So total journey will be 2x. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಆ ಕಾರ್ ಏನು ಮಾಡ್ತಾ ಇದೆ? A ಇಂದ D ಹೋಗ್ತಾ ಇದೆ. ಹೋಗುವಾಗ 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ವೇಗದಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. ಜವದಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. ಬರುವಾಗ 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ಗೆ ಹೆಚ್ಚುವರಿಯಾಗಿ 50% ವೇಗದಿಂದ ಬರ್ತಾ ಇದೆ. ಹಾಗೆ ವಾಪಸ್ ಬರುವಾಗ ಅದರ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಎಷ್ಟು, ಎವರೇಜ್ ಸ್ಪೀಡ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿರೋದು. ನೋಡಿ, ಎ ಮತ್ತು ಬಿ ಮಧ್ಯೆ ಇರೋ ದೂರವನ್ನು ಎಕ್ಸ್ ಅನ್ಕೊಳ್ಳೋಣ. ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಎ ಅಂಡ್ ಬಿ ಮಸ್ಟ್ ಬಿ ಎಕ್ಸ್. ಸೊ ದಟ್ ಫ್ರಮ್ ಎ ಟು ಬಿ ಎಕ್ಸ್, ಫ್ರಮ್ ಬಿ ಟು ಎ once again x. The total distance traveled by the body will be, car will be 2x. Hope you understand. Okay. Therefore, average speed is equal to, we know the formula, total path length divided by total time. What is total path length? X in one direction, X in one direction, X in opposite direction to X. What is time? C. From A to B, it is moving with the velocity of or speed of 40 meters per second. Okay? Somewhere here I will write. From A to B, its speed is 40 meters per second. From B to A, 50%, 40 into 50%, we know how to write 50 by 100. This much speed increased. To calculate this, first calculate what is 50% of 40. What is 50% of 40? Very easy. By ಲೆಕ್ಕ ಅದು 50% of 40 ಎಷ್ಟಪ್ಪ? 50% of 40 is 20. Half of that. See, 0, 0, 0, 0. 5 into 4, 20 meters per second. This 20 meters per second gives you idea about what? Increase in the speed. No, 50% of 40 meters per second. But to get increase in the speed, what you have to do? So, increase in the speed is equal to original 40 plus this 20 is equal to 60 meters per second. I write here. Increase is equal to 40 original 20 50%. What we get? 60 meters per second. 60 meters per second is the velocity of that car while returning from B to A. While returning from B to A. Hope you understand. Correct? Why I am telling? This is common sense. A car moving with a velocity of 40 meters per second will definitely take some greater time. ಒಂದು ಕಾರು ಏಜಿಂದ ಬಿಗ್ ಹೋಗ್ಬೇಕಾದ್ರೆ 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಹೋಗ್ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಸಮಯ ಜಾಸ್ತಿ ಬೇಕು. ವಾಪಸ್ ಬರಬೇಕಿದ್ರೆ ಅದು 60 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಬರ್ತಾ ಇದೆ, ಆಟೋಮೆಟಿಕಲಿ ವಾಪಸ್ ಬರುವಾಗ ಟೈಮ್ ಕಡಿಮೆ ಆಗ್ತದೆ. ಸಿಂಪ್ಲಿ ಹೇಳೋದಾದ್ರೆ ಹೋಗ್ಬೇಕಿದ್ದ ಟೈಮ್ ಬರಬೇಕಿದ್ದ ಟೈಮ್ ಒಂದೇ ಆಗಿರೋದಿಲ್ಲ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅನ್ಕೋತೀನಿ. ಹೋಗ್ತಾ ಇರೋ ಟೈಮು ಬರ್ತಾ ಇರೋ ಟೈಮು ಒಂದೇ ಆಗೋದಿಲ್ಲ. ಹೋಗುವಾಗ 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಹೋಗೋದ್ರಿಂದ ಸ್ವಲ್ಪ ಟೈಮ್ ಹೆಚ್ಚಬೇಕು, ಬರುವಾಗ ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗೋದ್ರಿಂದ ಟೈಮ್ ಕಡಿಮೆ ಆಗ್ತದೆ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ನಮ್ಮ ಡೈಲಿ ಲೈಫಲ್ಲಿ ಹಂಗೆ ಅಲ್ವಾ? ತುಂಬ ವೇಗವಾಗಿ ಹೋದರೆ ಬೇಕಾಗೋ ಸಮಯ ಕಡಿಮೆ ಆಗ್ತದೆ. ತುಂಬ ಸ್ಲೋ ಹೋದರೆ ತುಂಬ ನಿಮ್ಮ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇದ್ದರೆ ಬೇಕಾಗೋ ಸಮಯ ಜಾಸ್ತಿ ಆಗ್ತದೆ. It's very much common sense. Correct? Say, this is equation 1. Equation 1. Okay. Now I will rub this. Now this problem is okay. Now, what next? I have to find value of T1 and T2. I have to find what? Value of T1 and T2. How? See, from A to B, speed is given by 40 meters per second. Distance traveled is x. Time is t1. Correct? Listen carefully or observe carefully. From A to B, A ಇಂದ B ಹೋಗಬೇಕಿದ್ರೆ ಅದರ ಸರಾಸರಿ ವೇಗ ಸಿಂಪಲ್ ಲಿಮಿಟ್ ಜವ 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಇದೆ. 40 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಜೊತೆಗೆ x ದೂರವನ್ನು ಹೋಗ್ತದೆ t1 ಸಮಯದಲ್ಲಿ. ದಿಸ್ ಇಸ್ ಜನರಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಆರ್ time required t1 is equal to cross multiplication x by 40. Say equation 2. This is equation 1. This is equation 2. Now I got expression for what? Time t1. Time will be x divided by 40. Correct? Okay. Here velocity of particle or car is, the velocity of car is 60 meter per second. Distance traveled once again same x, but the time is not same. Less time, little less time compared to initial stage. So it will be 60x divided by t2, or t2 will be equal to x by 60. This is equation 3. Okay. ಇದು ಬೇಕಾಗ ಇದು ಬೇಡ ಇದನ್ನ ಬಿಟ್ಬಿಟ್ಟಿದ್ದೀವಲ್ವಾ ಸರ್ ನಮ್ಮ ಇಕ್ವೇಶನ್ ಏನಾಗಿತ್ತು ಎವರೇಜ್ ಸ್ಪೀಡ್ is equal to 2x divided by t1 plus t2 ಆಗಿತ್ತು t1 ವ್ಯಾಲ್ಯೂ ಅಲ್ಲ t2 ವ್ಯಾಲ್ಯೂ ಅಲ್ಲ ಇದರಲ್ಲಿ ಹಾಕಿ ಏನಾಗುತ್ತೆ ಈಗ 2x ಹಾಗೆ ಇರುತ್ತದೆ t1 will be x divided by 40, t2 will be x divided by 60. What next? Now simple mathematics, you have to follow mathematics which you have studied in your SLC level. SLC level mathematics system. ಇವೆರಡು LCM ಮಾಡಿ LCM ಎಷ್ಟಾಗುತ್ತೆ ಇಲ್ಲಿ ಮಾಡಲಾ somewhere here. Okay, LCM ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ LCM of 40 and 60 20 ಮಾಡುವ 2 and 3 multiply ಮಾಡಿ okay 2 3 6 2 3 6 6 into 20 will be 120. Your LCM is 120, so is equal to 2x divided by ಇಲ್ಲಿ 120 ಬಂತು correct. ನಿಧಾನ ವಿಚಾರ ಮಾಡಿ 40 3s are correct, it's 3x plus 60 ಇದೆ 62 sir 2x. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಂತ okay, hope you understand. Okay, now ಇದು ಬೇಡ okay. Now average speed is equal to 2x ಇದೆ ಇಲ್ಲಿ divided by 3x 5x ಆಯಿತು divided by 120 or 2x divided by 5x into 120. ಇದರ ಅರ್ಥ ಆಗಲ್ವಾ ಮನಿ ಬರೀತೇನೆ into 120 divided by 5x. ಈ ಟರ್ಮ್ ಅನ್ನ ನ್ಯೂಮರೇಟರ್ ತಗೊಂಡು ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ ರಿವರ್ಸ್ ಆಗುತ್ತೆ ಏನಾಗುತ್ತದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ ಕರೆಕ್ಟ್ ಅಲ್ವಾ ಈ ಟರ್ಮ್ ಅನ್ನು ವಾಪಸ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ ಕರೆಕ್ಟ್. ಸೊ x ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು 5 1 time 5 1 2 ಇದರಲ್ಲಿ 10 ಕರೆಕ್ಟ್ 40 24 is 5 4 20 24 into 2 is equal to 48 meter per second is the average speed. 48 meter per second is your average speed. Correct? Right? Okay. What about your average velocity? Now I have to draw no other book. This is A, this is B, okay? This is X, this is 40 meter per second in one direction, 60 meter per second, okay? Okay. All things are okay, but see here, displacement we have to calculate now. Average velocity is equal to displacement divided by time. Say time into whatever it will be. From this point to this point, you have traveled in first instant. Next instant, from this point to this point. Irrespective of your speed, you have traveled starting from point A and reached to the same point. As you have started from point A, reached A, your initial position coincides with final position. Correct? Swati. Your initial position is coincides with what? Your initial position coincides with what? Final position. So your velocity will be 0. Displacement is 0. Displacement is 0. Hence the whole equation is this. It's 0. No doubt in that. It is 0. Correct? Why? Your initial and final position coincide. There is no displacement. Hence it's 0. This is one of the most important problems I have seen. Okay, most of the teachers, lecturers used to solve such kind of problems while delivering this lecture. It's useful in your competitive exams also. Okay. By finishing this, I want to start within 15 minutes. Okay, almost 36 minutes I have taken. Within 15 minutes, instantaneous velocity without touching very much mathematics or something. I will just try to explain physical meaning of your instantaneous velocity. Of course, it's important to know mathematics. At the end of this chapter, we will try to understand mathematics behind this instantaneous velocity. And for time being, let us understand what exactly you mean by instantaneous velocity. Okay. Imagine you are moving in a straight line, in a straight highway, in a straight path. See, this is path you are traveling. This is O. Okay, this is somewhat X in this direction. Let me take a very simple example. Okay, we are moving in such a fashion that this is 1 second, 2 second, 3 second, 4, 5 second, 6 second, etc. This is time axis. Okay, I have taken X now. Let me take it as a time axis. Okay, time axis. In first interval, you are moving around 10 meter per second. Second say 20 meter per second, 30 meter per second, 25 meter per second, 40 meter per second, 50 meter per second, or whatever. Okay. Listen. Your speed, your velocity, you are moving in a particular direction, right? Between 0 to 1 second is 10 meter per second. At that instant it is 10 meter per second. From 1 to 2, it is 20 meter per second. Okay? From 2 to 3, it is 30 meter. Okay? What if you want this average speed or speed simply, velocity, okay, take out the speed, velocity at 1.5 seconds. What if you want to calculate its velocity at 1.7 seconds or 1.3 seconds? The velocity of an object at a given instant of time, at given instant of time is called instantaneous. Instantaneous velocity or simply velocity. What instantaneous means? Velocity of particle at that instant, particular instant. Here instant means akshana, exact time. But we express average velocity in terms of what? Interval. What do you mean by interval? Interval means some initial value and some final value. It's applicable for our time also. Time interval. How to express at exactly 1.38 seconds? How to express exactly 1.7? It is 1.7 seconds. There, what I mean to say is, in average velocity, we need some interval. At that interval, to overcome such situation, Sir Isaac Newton introduced a new branch of mathematics called calculus. Calculus. Here, here we have to use a concept called differential calculus. Differential calculus. What is differential calculus? Time interval. What you have to make? You have to make infinitesimally. Infinitesimally small. Vanishingly small. What do you mean by infinitely small? See, you want velocity of an object exactly at 1 second. Visible? I will write here only. In this graph, you want time interval, time instant exactly 1 second only. Now you just divide this time interval so small, like 0.9 to 1.1, correct? Here 0.9 is t1 initial time, 1.1 is final time interval. Your time 1 second lies between these two values, correct? Lies between these two values. What is difference? What is difference between these two? Delta t will be very small, 1.1 by 0.9, correct? So 0.2, correct? Or makes time interval. So here time interval will be 0.02 or make time interval. Here I will write delta t is equal to, where is okay, 0.00. What velocity? Instantaneous velocity is defined as limit as time interval tends to 0. Your average velocity is defined as derivative of x with respect to time interval. Coefficient of x with respect to time. This is the coefficient of x. It's called derivative. Here we have some standard formulae to be remembered. In case of differentiation, we have to remember some standard formulae. Or this v is equal to dx by dt. This dx by dt is called differential form of velocity. You have to remember velocity in this form. Not simply x by t, dx by dt. Time rate of change of position. Time rate of change of position. The rate of change of position with respect to time. In differentiation, delta t tends to 0, delta x divided by delta t. Limit delta t tends to 0, delta x divided by delta t, which is equal to derivative of x, coefficient of x with respect to t. By this definition, we can define velocity as time rate of change of velocity or rate of change of it is a limit. It is a limit to average velocity. It is a limit to average velocity at which time interval is infinitesimally small. Instantaneous velocity is defined as limit of average velocity at which your time interval is infinitesimally small, at which your time tends to 0, tending to 0, approaches to 0, all terms are equally used. Your time approaches 0. Means the interval is very small. Mathematically it is possible. Instantaneous speed. Simple. Imagine you are moving in a straight highway in a bike. You are moving in a particular direction with some speed. The speedometer of your bike, the speedometer of your car will show some reading. Correct? On bike is a speedometer irtade. Hesaru nodi speedometer anta correct? Adukondu accelerator irtade. Accelerator term ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಯಾವುದೇ ವೆಹಿಕಲಿನ ವೇಗವನ್ನು ವ್ಯತ್ಯಾಸ ಮಾಡೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸಲರೇಟರ್ ಇರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ. ಹಾಗೆ ಒಂದು ವೆಹಿಕಲ್ ಒಂದು ಸ್ಪೀಡೋಮೀಟರ್ ಇರ್ತದೆ. ದಟ್ ಸ್ಪೀಡೋಮೀಟರ್ ಗಿವ್ಸ್ ಯು instantaneous speed of your vehicle at that moment. There is another definition for instantaneous velocity. Velocity of a given particle at that instant. At given instant is also called instantaneous velocity. What exactly is the difference? With the direction it is velocity, without direction it is speed. How to define instantaneous? Instantaneous velocity is called instantaneous speed at that moment. Magnitude of instantaneous velocity is called instantaneous speed. For example, at time t is equal to 1 second, velocity is 25 meter per second. Okay, in other direction. Okay, here in this chapter we use plus and minus to mention direction. Plus 25 meter per second in one direction, minus 25 meter per second in other direction. In both the case, your speed is 25 meter only. This is a speed with the direction. This is a velocity with the direction. This is a speed. Let me repeat. These two values represent velocity with the direction plus and minus. This represents magnitude. This is the amounts will move fast. What you have to do? You have to understand things fast and fast. Thank you for watching the video.